Hello and welcome to Chapter 8, Section 6. This is where we choose a factoring method. How do we decide whether something is completely factored? Well, the first thing we want to do is look for a greatest common factor. That's the easiest way to stop and check. And then you want to look for a pattern. Now you've got a pattern in the difference of squares, and you have a pattern in the perfect squares trinomials. So you want to look and see if your numbers fit that as well, particularly after you take out anything that they all have in common. And remember, if you have something that's in the format of ax squared plus bx plus c, you're going to look at the factors of a and c and decide if any of those sums equal b. If you just have an x squared plus bx plus c, then remember the sum is b and the product is c. And then you want to check for any common factors that it has. Maybe you can pull a common factor out of these two and a common factor out of those two, and then we do the factor by grouping, particularly if it's a great big polynomial. So it's a big list to go down and check, but it's essentially reviewing every other section that we've done. So it's a good list to have. Please make sure you write this down because this is going to get you through your test. So let's start with an example. Negative 2xy squared plus 16xy minus 32x. We're going to factor it completely. So we're going to start by looking for a GCF. Well, all the numbers are divisible by 2. And I'm not going to just take a 2 out. I'm going to take a negative 2 out to get rid of that negative sign. So I'm going to pull a negative 2 out. I also see that everything has an x. So I'm going to pull that out too, and let's see what we've got. If I pull negative 2x out, I've got y squared minus 8y plus 16. Now I'm looking for patterns. Well, I've got a squared here and a squared there. Is this a perfect square? If it's a perfect square, I'm going to look at y minus 4 to see if that works. So 1 times 4 times 2, that equals 8. So this is a perfect square, which means this, this is my answer. Let's try it on this one, 2x cubed plus 8x. Well, the numbers have 2's in them, so I'm going to divide by 2, and the numbers have 1x in them. So I'm left with x squared plus 4. And this could be a perfect square as well, because the first one's a square and the second one's a square. So we're going to have a look at it. So the square root of x squared is x, and the square root of 4 is 2. Is this that squared? So we're going to go 2 times 1 times 2, and that doesn't equal that middle number. You need a middle number for a perfect square trinomial. You need it to actually be a trinomial. So perfect square doesn't work. Is there another pattern here? I have an a squared plus a b squared. Does that mean anything? Well, it really only means anything if that's a minus sign. A squared minus b squared is something, but a squared plus b squared isn't. Can I factor anything else out of there? No. Does it have anything else in common? No. Can I group anything? No, which means this is the final answer. Let's try another one. This one looks like it's already done. The question is it factored completely? So looking at this one, yes, there's nothing that x and 5 have in common, but check this out. We could actually pull a 2 out of here. So we could say 2 times x plus 3 times x plus 5. Now it is factored completely. Have a look at what they've got on, check it out, number 2. On the top of page 587, there are 2 problems there. Pause here, give them a shot, come back when you're done. For 2a, we're looking at this problem, and we can pull a 4x out of all of this, which leaves us with x squared plus 4x plus 4, and this is a perfect square trinomial for x plus 2. So this is our final answer. For B, we pull a 2y out, and we end up with an a squared minus b squared scenario, and we know that that means x minus y times x plus y, plus keeping that 2y. Okay? Let's try some more. 2x squared plus 5x plus 4. Well, there aren't any common factors to pull out, so we have to look at this through the ax squared plus bx plus c pattern, where we're looking at trying to find the factors. So we're going to look at 1 and 2, and these are both going to be positive, so this is going to be 4 and 1, 1 and 4, 1 and 2, 2 and 2. Oh, I guess I don't need two of those. And we're going to add these, and we're going to go outside, inside. So this is 1 plus 6, and that's not 5. 4 plus 2 is not 5. 2 plus 4 is not 5. There aren't any answers to this, which means this is unfactorable. It's always scary when you find those because you're like, what did I do wrong? Let's try this one. Well, I can see that we're going to take 2 n's and a 3 out of everything. So we're going to take out 3n squared, and we're going to be left with n squared minus 5n plus 4. And the question is, can we do anything with this to factor it? So now we are going to have two negative numbers that add together to make a negative. So we've got, so to make 4, we've got 2 and 2, we've got 4 and 1, and 4 and 1 are going to make 5. Remembering that those are both negative numbers, we've got n minus 4 and n minus 1. And that's what's going to give us our negative 5n, and we're going to remember to bring that down. This is our fully factorable equation. Here I can pull out, I can't pull out a 4, but I can pull out a 2, and everything has an x. So if we pull 2x out, I have 2x squared plus 9x plus 10 left over. So we're going to look at 2 and 1, 2 and 1, two things to make 10. So we can say 2 and 5, 5 and 2. Let's see if those work before I do the other ones. 10 and 2 is 12. 4 and 5 is 9. So this one is going to be our answer. So we're going to pull down our, well, let's do it down here. We're going to pull down our 2x times 2 plus 5 times 1 plus 2, oops, x. There we go. This is our fully factorable answer. The last one we have right here is this one. I'm going to start by pulling a p out. That's going to give us p to the 4th minus 1. And this is an a squared minus b squared scenario. And we remember that that means we have p squared plus 1 times p squared minus 1. And those are fully factored. Look good? So we've got one with a pattern. We've got one with an ax squared that was factorable, one with an ax squared that was not factorable, and one that we can factor out the ax squared, so it gives us something we can work with. So try checkpoint number 3 on page 588. Pause here and come back when you're done. So number 3a, we have an ax squared scenario here because there's nothing we can factor out, and we end up with this answer. With b, we can factor out a 2 from everything and 3 of the p's, which leaves us with this trinomial, which is factorable. and it's a little easier to factor that way. And in C, we can factor out a 3 and 4 of the q's to start with. That gives us this trinomial, which leaves us with these two factors. And then with D, we factored out the 2, but a squared plus b squared doesn't get us anywhere. It's actually fully factored just like this. So your homework tonight is to do numbers 21 to 54 every third problem. And that's actually a little more than 12 points because one of them has ABC, but it's not too bad. And then we start the review, and you're doing 1 through 123 odd. That's 62 problems, and you've got a couple of days to do that. So take the time to make sure that you're doing these well and thoroughly, and remember, don't check the answer every time you do it. Check the answers at the end of each section or at the end of the whole thing so that your confidence grows better. Okay? If you have any questions, please ask, and I will see you tomorrow. Take care.